Is necking always present before material fracture? Imagine pulling on a piece of metal or plastic and wondering what happens just before it snaps. Do you see a tiny change in shape, or does it break suddenly? Today, we're going to explore whether necking always shows up before a material fractures. When materials are stretched, they go through different stages on a stress-strain curve. In ductile materials like many metals, after they yield, the stress increases to reach the maximum point called the ultimate tensile strength. After this peak, the material often starts to thin out in a specific area, which is called necking. This localized reduction in cross-sectional area is a sign that the material is about to break. Necking happens because the material can no longer distribute the stress evenly. The deformation becomes concentrated in one spot, making that area thinner and weaker. This process is common in ductile materials because they can absorb a lot of energy and plastically deform before breaking. So, in these cases, necking is almost always seen before fracture. But what about brittle materials? Think of glass or ceramics. These materials don't stretch much before breaking. They tend to fracture suddenly with very little plastic deformation. Their stress-strain curves are nearly straight lines up to the point of fracture. In these cases, necking does not occur because the material does not undergo significant plastic deformation. Instead, they break quickly and cleanly, often with a flat or shiny fracture surface. The key difference lies in how the material responds to stress. Ductile materials can stretch and form a neck, which signals that failure is near. Brittle materials fail without this warning sign, often breaking without any visible necking. From a scientific point of view, the presence of necking can be predicted using the consider criterion. This rule states that when the work-hardening ability of a material diminishes enough, necking will start. Since brittle materials do not work-harden much, they do not show this stage. In practical engineering, understanding whether necking occurs helps in designing safer components. For ductile materials, necking indicates energy absorption capacity, which is useful in forming processes. For brittle materials, the absence of necking means failure can happen suddenly, so engineers need to be extra cautious. To sum up, necking is a feature of ductile materials that appears before fracture, but it is not always present. Brittle materials tend to fracture without necking because they do not undergo significant plastic deformation. So, the answer is clear. Whether necking occurs depends on the material's ductility and how it deforms under stress.